So for a question like 5, I don't really see a radical. Now this power of 1/2, this is one of the special ones that I suggested you memorize the other day. With this, fractional exponents, remember, are power over root, where the root goes into that little check part of the radical. Oops. And the power is what the inside is going to continue to get raised to. So for this one, my root is 2 and my power is 1. So I convert this into a radical. Now this one is special because that first power, anything to the first, is itself. And a root of 2 is your regular square root. Now you do not have to show every single one of these steps. You can just go straight into converting that into the square root if you recognize it without having to hit all those steps along the way. And now you're in a regular radical equation. Step 1, isolate the radical. So I'm going to subtract my x over. I get radical x minus 5 equals 7 minus x. They are not like terms, so they cannot combine more than that. Step 2, square both sides. The squared and the square root cancel out. I'm left with x minus 5 equals, again, 7 minus x squared. You're going to be doing 7 minus x times 7 minus x and double distribute. So 7 times 7, 7 times negative x times 7, negative x times negative x, positive x squared. Now, as I combine like terms, negative 7x and negative 7x to get negative 14x, I'm also going to do a little rearranging so that the right side is in standard form, and I get x squared minus 14x plus 49. Remember, when you're solving with an exponent, you want to set it equal to 0 and then factor. So I'm going to subtract the x from the leftover, add the 5 from the leftover, and I get 0 equals x squared minus 15x plus 54. From here, we have our simpler AM method. X squared is x and x, adding to negative 15, multiplying to positive 54 is a negative 9 and a negative 6. I then set each one equal to 0 separately. Add the 9 on one side. Add the 6 on the other side. From there, you are still doing a check. This is still a radical equation, so it still requires a check. Now, it really does not matter if you go to the absolute original or the one where you rewrote it as the radical, because they do mean the same thing. I'm going to go back to the first original. I'm going to start by plugging in the 9. Once again, just plug the one side into your calculator. So parenthesis 9 minus 5. Do the exponent button above the division sign. 1/2. hit the arrow key to come down, and then plus 9. So we get 11 on the left, and we had a 7 on the right, which is not possible. So that 9 rejects. So now I'm going to test out the 6 the same way. Plugging that one into my calculator the same way I plugged in the first one. I get a 7 for that left side, which is what I had on the right side. So my answer here is the positive 6. Question 6. Same thing. If you recognize those exponents, those are radicals. So the first thing I would do would be to convert them from those exponents into radicals. Now step 1 says isolate the radical. Since there are 2 radicals, I do want them both isolated, which means I need them on separate sides of the equation. So I'm going to add that negative 1 over. So I get radical x plus 6 equals radical 2x minus 4. From there, step 2, square both sides. The squared and square root cancel on the left, and they cancel on the right. From there, no exponents, so we don't have to set it equal to 0. We can go straight into getting the x's on one side, numbers on the opposite side. I'm going to subtract the x over. Then I'm going to add the 4. So we get that x equals 10. From there, we are going to do the check. Plug the 10 in for x into the original equation. I'm going to take the left side and plug it into my calculator like I've been doing. Be careful when you plug stuff into your calculator that you're typing it in correctly. So we do get a 0 on the left, which is also what we have on the right. So my answer is the 10.